Hyrule is a land of magic, monsters, and a world so mysterious, it's basically a conspiracy theory. Right behind me is an incredible view of the southern sea of Hyrule, and a normal person might enjoy the view, watch the sun go down, and then move on to the next shrine or Korok puzzle. But I am anything but normal, and this horizon is looking incredibly flat to me. In fact, if you drew a line across it, you'd see it has zero curvature, which is suspicious. Very suspicious. Because in our world, we can clearly see a curvature on the horizon at a high enough elevation. And this is just one method scientists have used to prove that our Earth isn't flat. And Hyrule? Well, there are quite a few things that make us doubt how round the world really is. My wife and I have been making Zelda science content now for well over a year, and in that time we discovered some strange oddities and inconsistencies that make us question Zelda's world. Like, how does Hyrule have a desert and a rainforest at the same latitude? That's not normal, even with the existence of rain shadows. Why are Hebra's mountains cold, but Death Mountain isn't, even though they are at the same latitude and elevation? And where is all the rainfall going? Because I don't know if you noticed, but it rains a lot here. Like, a lot. Well, it took some time, but we finally came to a single theory. One that might explain all of these inconsistencies. And, if true, would change everyone's perspective on their favorite action-adventure video game series. But there are no conspiracy theories here today. No, we set out to scientifically prove or disprove if Zelda's world is actually flat. For most of Earth's history, humans have pondered our place in the universe, and for much of that time, the people of the past thought the Earth was flat. They also believed in sea monsters too, and it's a good thing those sea monsters were around. You know, so that people didn't sail right off the edge.
Oh no!
Sploosh.
In fact, most of humanity continued to believe in a flat Earth long after the early Greeks were measuring the globe. As early as 350 BC, Aristotle was looking at the cosmos to learn about the shape of the Earth. He looked at the shadow of the Earth on the moon and the visibility of the constellations to build his theory of a round Earth. Just 100 years later, Aristophanes used the length of shadows to definitively prove the Earth is round. He also measured its size almost perfectly in 240 BC. Good job, dude. And a few hundred years after that, Pliny the Elder wrote a 37-volume encyclopedia called Naturalis Historia. He dedicated the whole section in the second book to reviewing all the evidence for a round Earth, and even added a bit of evidence of his own. As commander of the Roman imperial fleet, Pliny the Elder spent a lot of time watching boats on the ocean from his villa window on the Gulf of Naples. And his observations are now called the light and mast evidence theory. So in order to figure out what is going on in Hyrule, we decided it was best not to try to reinvent the wheel here, or at least not too much. We made a list using all these historic methods to see if Zelda's world is in fact round. And while we were exploring the evidence, we added a few oddities of our own to explore. So to scientifically analyze the shape of the world, we will look at these things. For each test, we will explore Hyrule in detail and evaluate each data point. Then we will categorize each test as either support for a round or flat world. But if the evidence is inconclusive, we will assign a gray dash. By the end of our journey, we will know for sure the shape of Zelda's world. So grab your measuring tools and get your field gear ready, because it's time to see how flat Hyrule really is. Well, we started our investigations where any normal Hylian would start, by trying to walk off the edge. We went as far as the map would let us go to see if we could find an end. But anyone that's ever played Tears of the Kingdom knows that there's visible land and ocean past the edge of the map.
Tower, this is Commander Link, over.
We read you, Commander Link. Go ahead. Over.
All systems here look good. Permission to begin test flight to Termina, over.
All systems read nominal Link. Permission granted. Got a speed.
Alright, here we go. All liftoff. Whoa, we're looking good. Looking good, Tower. Pressure and altitude look good. I think we'll be in Termina in about approximately an hour.
All systems look good here, Link. Keep her steady.
Increasing altitude, going over and leaving. Tower, I might, Tower.
What is it, Link?
I think we have a problem.
And obviously, because of video game logic, there's an invisible wall stopping you from going any further. Darn Nintendo developers, making your video game enjoyable and, well, video gamey. But aha! That doesn't stop a curious man like me. I have free cam. So what lies beyond the borders of Hyrule? Is there an end to Zelda's world? Well, there's a whole bunch of world out there, rendered as poorly as Roach's pathing mechanics in Witcher 3. How on earth did he actually get up there? But more importantly, we couldn't find any trace of an end. West of Gerudo, it's just sand, and then poorly rendered ocean as far as the eye can see. You've never noticed it before, because the game stops you and throws up a sandstorm veil to block your view. South and east of the continent, just miles of ocean. Oh, but the north, well, that's actually more interesting. After you jump the bottomless pit, there's more land. For miles and miles, hills and valleys of grass. And after a few moments, more ocean. So that means the entirety of Hyrule is surrounded by ocean. But that doesn't make Zelda's world flat. It just means that Hyrule is on a small island. And I guess that just makes our first check pretty much inconclusive. So now we're back to square one. Science is never easy, is it? Well, nothing worth doing hardly ever is. If there is no clear end to Zelda's world, what else could a Hylian do to investigate the world's shape? Well, our next check is an oddity we noticed during our investigation into the amount of rain Hyrule gets. The Aurora Borealis. If you are journeying through the Hebra Mountains on a clear, starry night, you might be able to look up and glimpse these beautiful lights. Now, in the real world, the northern and southern lights are caused by Earth's round magnetic field. The Aurora Borealis is created when charged particles from the sun collide with gases from the Earth's atmosphere. If you watched our radioactivity video, you already know about ionizing radiation. This happens when high-energy particles carried on the solar wind are literally smashing apart the oxygen and nitrogen atoms in the atmosphere. The outer electrons get ripped off, leaving behind a positively charged atom. And when that atom finds some electrons to add back, well, it creates that beautiful green and purple glow. It's so beautiful, in fact, you might have forgotten your feet have gone numb and that you developed frostbite on your right big toe. Maybe next time, build a campfire, Link. But what does that have to do with Earth's magnetic field? Well, without a magnetic field, the sun's radiation would hit the entire atmosphere at once. And that means you technically would have an Aurora Borealis everywhere. But it would be so weak that you wouldn't be able to see it. Earth's magnetic field changes by literally catching the solar wind and pushing it towards the North and South Pole. This intensifies the radiation and causes that amazingly beautiful light show. You can think of it like a hose nozzle. Turn on the mist setting and, well, everything's a little bit wet, but you aren't creating much of a splash. Turn on the jet stream though? Well, now the water is concentrated into one spot, and suddenly your tomato plants aren't looking so good. And what's even cooler, or rather hotter, Earth isn't like a fridge magnet. It's not made of solid iron. Its magnetic field is made by its melted, swirling iron core. The swirling iron creates an irregular dipole field around the north and south poles, which means that we get beautiful, dancing, moving lights shaped like giant circles on Earth. But that's not what happens in Hyrule at all. Hyrule has northern lights, sure, but you can only see them from a single mountaintop in Hebra. Talk about a vacation destination. I can't believe Hyrule's Hudson construction hasn't built a resort up here yet. I just imagine Addison standing up here trying to get new customers. Poor guy. If Zelda's world were a globe with a swirling molten iron core, that radiation would be funneled to the entire northern rim. Both Eldin and Akla should then be glowing just as bright as Hebra. But since they're not, well, that means no global magnetic field is guiding the sun's radiation. So what could be causing such a small light display over Hebra? Well, given the intensity of the lights, there must be some magnetic field. And there are only 3 major ways to create large magnetic fields. Now, we've already ruled out one of those options. There is likely no molten iron planetary core here. Option 2, though? Well, it's to run electricity through a large coiled wire. When electrons sit still, they have an electric charge, but once they start moving, that electric charge creates a magnetic field. You can think of a magnetic field like wind from a moving train. When the train sits still, there is no wind, but when it gets going fast, it creates an extra field of wind around it. And as funny as option 2 would be, I think we can rule it out because the mountain is clearly not wrapped in copper wire. So then, what's option 3? Well, bar magnets. If the mountains of Hebra had a substantial amount of cold solid iron, they could be making their own localized magnetic field. That would be cool. Pun intended.
Oh, brother, this guy stinks!
Electrons are always moving and orbiting their atomic nucleus. But when electrons all spin in the same direction, that creates a stable magnetic field, just like the magnets on your fridge. So, if the mountains were filled with solid iron, they could be making a local magnetic field and catching the radiation from the sun. But where does that leave us? Does this support the hypothesis that Zelda's world is flat? No, not necessarily. But it does mean it's not a large spinning planet like Earth. And we'll come back to Earth's spin later in this video. But for now, we will say that no hot spinning core is good supporting evidence for a flat world. Oh, and there's even more evidence that Zelda's world definitely doesn't have a molten iron core. Not only is there no global magnetic field, but we would feel that heat in the depths. And that brings us to the next test on our table. You see, Earth, the deeper you go, the hotter it gets. Sure, surface caves might be cool and damp, but deep in the Earth, like as deep as the depths are, it would be upwards of 122 degrees Fahrenheit or 50 degrees Celsius. That's pretty hot. See, when round planets are created, iron and other heavy metals sink to the core due to gravity, and the radioactive materials and leftover heat from creation keep that core hot. This causes the Earth's geothermal gradient, which means the closer you get to the molten core, the hotter it gets. Since Link doesn't need to wear his heat-resistant armor in most of the depths, that means the world doesn't have a hot core. Obviously, Death Mountain is different, but yeah, that's a whole other video. We'll add it to the list. You know, it's funny, we have been recently asked by a member in our Discord how many video ideas we have, and they couldn't believe it when we said that our current working list is 80 videos. Well, 81 now. So at our current rate of video release, it would be over 7 years of content. Yeah, maybe consider subscribing if you haven't already. We have a lot planned. Anyway, that cold core beneath Hyrule puts the globe theory at an even greater risk. Because if the world is flat, And that would mean the pressure in the middle, where the core would be, is more distributed. That means the core could cool faster, creating a solid metal layer. Cold depths and no global magnetic field could definitely be evidence for a flat world. But you might be thinking, MamaGoron, what about the Venturi effect? Couldn't the Venturi effect be cooling all of the depths? Well, maybe. See, in Tears of the Kingdom, a whole bunch of vertical shafts opened into the depths, and that means air can start circulating. The Venturi effect happens when a fluid, like air or water, accelerates through a constricted path. The acceleration decreases the pressure and creates suction. And if you have two tubes at different elevations, this suction creates a draft. And we aren't the only ones that use the Venturi effect. Sure, we use this science to cool minds and even intensify fires in the industry, but animals, yes, animals use this too. The most famous example is prairie dogs. Prairie dogs dig ventilation tunnels into their burrows, one high and one low, to keep a nice, cool breeze in their underground homes. Can I do this for my house? The other question is, would that make me a hobbit? You can drink your fancy ales, you can drink them by the flagon, but the only ale for the brave and true comes from that green dragon. I don't know if is it drink green dragon? So is that what is happening here? Well, no, probably not. It could definitely be contributing, but we aren't seeing much wind in the depths. I mean, look at all the particles in the air. They're just sitting there. And also, these shafts, they're brand new. If the core were hot, we would see evidence of it. There wouldn't be pools of water and plants and animals that look like they adapted to cold and wet. We would see a lot of steam and almost no plant or animal life. So we're going to call it. That's a check mark for a flat world. Though as we were exploring the depths, we noticed something else strange. Did you know that the depths are a one-to-one recreation of the overworld? It is mirrored in a sense, but not like Stranger Things upside down. Because every major landmark on the surface, we see the same in the depths. But rivers became cliffs, mountains became valleys, and history became legend. Legend became myth. And for 2,500 years, the ring passed out of all knowledge, until whence came, it ensnared another bearer. Wait! Gosh, dang it. Sorry, wrong universe. I'm on some Hobbit kick today. Sorry, where was I? What's wrong with the depths? So, what's wrong with the depths being a recreation of the surface? Well, other than the fact that there is literally nothing holding up the weight of mountains, that can't be good. If the world were a globe, the depths would be smaller. Think of the world as a slice of pie. As you move towards the center, the slice gets narrower. So instead of being an exact recreation, we should see compression. If two shrines are 1,000 meters apart on the surface, the corresponding light routes in the depths should be closer. But the exact coordinate matching here only makes sense on a flat world. Is it technically possible to make things match up on a globe? Sure. The bigger the world, the more likely that is. But Hyrule is tiny, like really tiny. So unless there is much more world than we know about, the world really isn't that big, and that slice of pie should get narrow fast. Great, now I'm getting hungry. I'm gonna have to go get pie after this. So if we assume Hyrule is on a fairly small world, the depths should be a lot smaller than the overworld. And that's another check for a flat world. Okay, so there is nothing but ocean off the coasts, right? And the magnetic field is all but non-existent. And the depths are cold and cavernous. So what's next for a Hylian researcher to explore to prove our world is flat? Well, What about just getting really high up and looking at the horizon? That would be definitive proof, right? And we wouldn't even need to go to outer space, because humans can see the curvature of the Earth from reconnaissance planes and high-altitude weather balloons. Yes! I knew all those times that I practiced flying those Zonai rockets would come in handy. Well, unfortunately, even with Zonai power, you can only get up to around 3,000 meters in this game. And that might be enough if the globe were small. But on our Earth, the curvature is so large that you would need to be up at least 20 to 30,000 meters to even see the curve at all. So unless Link is ready to recreate the Red Bull Stratus jump, this isn't something we will ever see in game. Hyrule's world would have to be 7 times smaller than Earth to see curvature at 3,000 meters. And that means, just like on Earth, the view of the ocean horizon from both the shore and the Sky Islands would look pretty much flat. It could be a huge globe or a really flat planet. But unfortunately, since we don't know for sure how big the world is, we have to call this one inconclusive. So is there anything we can learn while we are miles up from the surface and too scared to look down? Actually, there is. See, the developers of Tears of the Kingdom added a very interesting feature to the Sky Islands. At sea level, the horizon in the game is beautiful and crisp. But on the Sky Islands, it's a graded blur of blue and gray. So what does that tell us? Well, that blur might be a symptom of a flat world. If the Earth were flat, you could see infinite distance, or at least as far as light could travel to your eyes. But that also means an infinite amount of atmosphere would be in the way. Sure, you could technically see into your friend's house from 3 time zones away, assuming you don't mind every speck of dust, pollen, or every bird feather floating over the Atlantic Ocean. Because see, air isn't transparent. If you watched our air quality video, you know the atmosphere is oxygen and nitrogen with water vapor and particulate dust mixed in. And all those particulates scatter light. We break airborne particles into 2 groups. In the first group, PM10, we have anything smaller than 10 microns like dust, pollen, and sand. In the second, we have PM2.5, and this is anything smaller than 2.5 microns across. That's tiny, and includes things like ozone and gases from volcanoes. When light waves hit a particle, they bounce off. And when light rays are not all going in the same direction, the image gets out of focus. So the further you can see, the more the atmosphere will scatter light, making the horizon look blurry. And that's why faraway objects on Earth tend to look blue-gray and fuzzy. But different air temperatures can also distort light, which causes a phenomenon called fata morgana. Have you ever seen a picture of a boat or a duck that looks like it's sitting way above the water? That's because the temperature inversions near the horizon bend the light, creating a complex mirage. In a temperature inversion, the air is flipped, and a layer of cold air is trapped underneath higher, hotter air. Cold, dense air slows down light. The speed difference literally bends the light and can cause illusions like floating mountains or even skyscrapers that are twice their actual height. So if you could see infinite distance, well, all the bent and scattered light rays from miles of heat and particulate matter would make things very blurry. On a globe, when you increase your elevation, the horizon actually gets crisper. You're seeing further away, but you're also seeing less atmospheric interference. The atmosphere thins higher up, so you aren't looking through thick ground level atmosphere, but instead you are looking through thinner and cleaner high altitude air. On a flat Earth, the horizon wouldn't be due to a physical curve where the world is no longer visible. The horizon is just the point where the air is literally too thick for you to see through. And on a flat plane, the further up you go, the thicker the atmospheric wedge you're looking through. That means light bending from particulate matter, water vapor, and temperature would all cause a blurrier image as you increase in elevation. So the higher up you go, and the further you could see, the blurrier the horizon becomes. And that's exactly what we see in Hyrule. There is a fairly crisp horizon at sea level, but as you head up into the Sky Islands, the true horizon is nearly indiscernible. Now Link has a good excuse for why he keeps missing all those paraglider landings. It's not a lack of skill, it's just atmospheric interference. And the world is starting to look pretty flat from where we are standing. Speaking of which, while we were standing there squinting with our eyes and tilting our heads to see the non-existent curve of the horizon, we noticed something else alarming. Nothing sinks.
Huh?
I don't mean sinking in the water, I mean sinking over the horizon. Remember Pliny the Elder from the beginning of this video? Well, let me explain his mass and light evidence theory for this next one. See, on a globe, faraway objects appear to sink over the horizon. As they continue over the curve of the Earth, they disappear bottom first. In his Natural History of the World, Volume 2, Pliny the Elder wrote that when a ship out at sea passes far into the distance, quote, the top of the mast appears slowly to sink, and finally, it is hidden from sight. That means that the last visible part of the ship is the lamplight at the top of the mast. This was also coined later as the hole first proof for a round Earth. So if the Earth is round, objects on the horizon should appear to sink. If the world is flat, well, they should become smaller and smaller until they disappear into a blur on the horizon. So what happens in Hyrule? Well, this is easiest to test on the water so that the horizon is relatively flat. We don't want any of those pesky mountains getting in the way. I'm talking about you, Death Mountain. Always causing trouble for us Gorons. Erupting and stuff. Well, at least it gives us some good food. So to test this, we headed to the southern coast of Hyrule for some horizon sleuthing. We started on the Minot River in Faron, right next to the huge boat on the river. As we made our way to the ocean, the boat got smaller and smaller and smaller, but it never sank. The same happens to the docks in Lurelin. Sure, the boxes on the docks might blink out of existence. Also, side note, if you're looking to hide your secrets, Lurelin is perfect. Just put them in the crate, walk 20 paces away, and watch your problems vanish into thin air. So yeah, I'm gonna need you to get into this box for me. But the docks and the trees just get smaller and smaller forever. They never sink or disappear. And that is a telltale sign of a flat Zelda world. Yikes. So is that it? Have we proved the world is flat? Well, no, not 100%. We haven't seen any evidence supporting a globe yet, but there are a few more checks we need to make to be absolutely positive. Because sure, maybe the world's core is cold and not magnetic, but that's technically possible on a small planet like Mars. The only problem? If the world were small, then the depths should be compressed. And also, we'd be able to see the curvature at a lower elevation. But maybe Zelda's world is on a huge globe, and that's why we aren't able to travel far enough to see objects sink over the horizon, or see the curvature, or even see the depths compressed. But all that evidence is about the air in the ground. What about biology? Do the placement of habitats, the forests, deserts, and grasslands tell us anything about the shape of the world? Well, if you watched our Rainfall in Hyrule video, you already know the answer. Yes, absolutely. See, Earth is a shape called an oblate spheroid. Even on a normal sphere, the equator would stick out towards the sun. The centrifugal force pushes the mass of the equator outward. That means the equator gets significantly longer and more direct sunlight than the rest of the world. So what does that have to do with biomes? Well, all that extra heat causes something called a Hadley cell. This is a global circulation of air caused by the heat at the equator. Hot, moist air at the equator rises and brings water vapor up into the atmosphere. As the air rises, it cools and creates clouds. The air is pushed away from the equator to the north and south, and as it moves, it dumps all that water as rain. And this is why tropical rainforests always fall between 15 degrees north and south. Then the cold, dry air sinks and creates deserts. And almost every desert on Earth occurs between 15 and 30 degrees north and south. Okay, so what does this have to do with Hyrule? Well, if the world were round with a fat equator, then we shouldn't see the rainforest of Faron at the same latitude as the Gerudo Desert. Could they be north to south neighbors? Sure, that's how they should be. But east to west? Absolutely not. And I hear you already getting your keyboards out to correct us, because believe me, we saw your comments last time. Papa Goron, what are you talking about? The deserts are created by rain shadows.
Haven't you heard of rain shadows?
Don't you know anything about rain shadows?
Actually,
rain shadows.
Bro was wearing a lab coat.
Rain
but
shadows.
Never heard of
My
rain
guy
shadows.
never heard
Rain shadows.
of a rain
shadows.
shadow before.
Rain shadows.
Rain
shadows.
Rain shadows.
Rain shadows.
Rain shadows. Look, friends, give Dr. MamaGoron a little credit here. Do you really think that a doctor with a PhD in biology who has been teaching ecology and environmental science for well over a decade hasn't heard of a rain shadow? Okay, so for those of you who weren't down in our comments, you might be wondering, what is a rain shadow? Well, a rain shadow is formed with almost the same mechanism as Hadley cells. Warm, wet air approaches a mountain and is forced upward. As the air rises, it cools. The water in the cool air condenses into clouds, and all that rain falls on one side of the mountain. So by the time the air gets across the mountain, it's dry, and that dry air falls down the other side of the mountain, creating a drier habitat. Sometimes it's a tropical dry forest or a grassland, and sometimes it's a desert. But the key word here is mountain. That's why this isn't happening in Gerudo. On Earth, some of the most famous deserts are created by rain shadows, like the Sahara and the Great Basin Desert, which includes Death Valley. But look at these heights. The Himalayas, on average, are 6,100 meters tall. The Andes, 4,000 meters. Sierra Nevada, 3,500 meters. Even smaller ones like the Cascade Range is around 2,500 meters tall on average. And what about the Gerudo Highlands? Well, that's the thing. Highlands aren't mountains. They are glorified hills. The Gerudo Highlands are around 275 meters tall on average, and the highest peak is only 472 meters. And even if we doubled those numbers, it wouldn't even be close to the height needed to make a rain shadow. In the real world, you usually need a massive continuous wall rock at least 2,500 meters tall to effectively squeeze the moisture out of all the clouds. And look, I live in the Appalachian Mountains. The ranges here average about 900 meters, with the highest peak being over 2,000 meters. And you know what? I don't see a desert here. And I know, because I hate sand. It gets everywhere. Ugh. Also, rain shadows make one slope of a mountain wet and green, all the way up to the peak. And on the other side, it's dry. There is no green slope on either side of the Gerudo Highlands. Sure, there is a grassland a bit beyond, but that's at low elevation. And look, all of these hills are brown. It's desert all the way across. So no, the Gerudo Desert is not created by an east to west rain shadow. which means the placement of the biomes is completely abnormal. Deserts and rainforests should not be together like this. Also, on the globe, the poles get less sunlight and heat. The far north regions of Hyrule should all be around the same temperature. Really stinking cold. If Hyrule is on a globe, the tundra and cold pine forests could not be at the same latitude as warm swamps and deciduous forest. None of this makes any sense. Globes have predictable patterns based on the angle of sunlight. We should be seeing temperatures decrease as we move north, and predictable bands of wet and dry climates moving north to south. So that's it. The world of Hyrule can't be a globe. That's another check for a flat world. And at this point, all the oddities and inconsistencies of Hyrule are pointing to flat. But there is still one set of evidence we haven't examined yet. Up until now, we've been looking at the world on the ground. But what if we look up to the sky? See, those Earth Greek philosophers looked to the cosmos to understand our world, its shape, and our place in the universe. Sometimes you have to look outward in order to see inward. But can we do the same thing in Hyrule, in Zelda? Well, as we looked up into the sky, the first thing we noticed is the sun is always to the south. Now, that doesn't tell us much about the shape of the world. But if Hyrule were a globe, this would put us squarely in the northern hemisphere. The only problem with that? Well, Lake Hylia and the Reservoir Lakes are convinced they are in the southern hemisphere. See, both of these lakes have a whirlpool that's spinning clockwise. And if this were on Earth, that would put Hyrule squarely in the southern hemisphere. That's because the Earth's spin causes something called the Coriolis effect. This is an apparent force from rotational inertia that causes objects like water and even airplanes to curve counterclockwise in the north and clockwise in the south. This doesn't work for toilets. They are too small. But for giant lake whirlpools, they would most certainly be affected. If I asked a Hylian scientist which way was north, he would probably just point to the floor. Because when the sky and the lakes are giving you information about two different hemispheres, down is the only direction you can really trust. So where does that leave us? Well, either Hyrule's globe is spinning in the opposite direction of Earth, or it doesn't spin at all. A backward spin would flip the Coriolis effect, but it would also flip the direction of the sun. And stick around, because we'll get to that sun in just a minute. But what we can say for sure is it's traveling in the same direction as ours on Earth, east to west. So the world definitely isn't spinning backwards. But what about with no spin? Well, that would mean that the direction of the whirlpools would be random. And the no spin theory here backs up everything we found about the core temperatures and magnetic fields earlier. So it's looking like Zelda's world really has no spin. But also, a world that isn't spinning would almost certainly be a flat one. See, science tells us that every planet must spin because of its birth in the swirling nebula. The collapse of a slowly spinning cloud of rock and gas coming together to make planets. And the force of compressing into a sphere always leaves behind a spinning force called angular momentum. You can think of this like a spinning ballerina or an ice figure skater. As she pulls her arms up and her legs in towards her body, her spin speeds up. So as rocks and gas come together closer to the core of the planet, the spin should also speed up. And that's why every planet in our solar system spins. So if Hyrule's world doesn't spin, that means it isn't anything like we've ever seen before. A planet created without that crushing and spinning force might be small enough that it wouldn't turn into a sphere. And that means we have another check for a flat world. Oh, and as we continue to watch the sun, we notice something even weirder. There are time zones, but like really messed up time zones. On Earth, time zones are caused by the rotation of the globe. We call noon the time at which the sun is the highest in the sky, but that isn't the same for every part of Earth. See, the Earth is a sphere that rotates 360 degrees every 24 hours. So to make local time match the sun, we divided those 360 degrees by 24 hours. In other words, every 15 degrees you travel east to west, you push the solar noon by 1 hour. But with an Earth-sized globe, 15 degrees is a really long way. Since Hyrule has a lot of grassland and temperate forest, it's probably somewhere similar to the middle of the United States. And if we take the distance and that kind of mid-northern latitude, then 15 degrees is around 1,300 kilometers, or a little over 800 miles. But Hyrule is not that big. So we honestly weren't expecting to see time zones like at all. But just to do our due diligence, we checked. We calculated time of the noon sun in Gerudo Desert, Lurelin Village, Rito Village, and on Death Mountain. These are places where it doesn't rain, like ever. So we were able to check the sun with clear skies day after day. We checked each location a total of 10 times at different elevations. And what we found was shocking. Hold up real quick, my dude. Okay, look, we did this whole video and then we realized we didn't really explain this experiment very well. And let me go ahead and break that down for you. Okay, so in each of these 4 locations, we decided to put Link where the sun would be the highest in the sky. That way you would know when noon is in each of those locations. Now, you're probably asking, how do you know if the sun is directly overhead? And that's where Majora's Mask comes into play. You know, the mask that like almost destroyed the world in one part. Yeah, we're actually using it to not destroy the world with the moon, but actually to see where the sun is the highest in the sky. Look, it works out in the end. Anyway, so Majora's Mask is interesting because there's actually 2, you might know this depending on if you play the game, there's actually 2 points on the mask, and those 2 points line up pretty well with Link's shadow and a stick. So if we put a stick right behind Link and we put Link, you will actually be able to get a way to see that the sun is directly overhead. So we did this in all 4 of the locations to find when solar noon actually was. I have to admit, this is pretty smart of MamaGoron. I would not have thought to use, well, Majora's Mask and a stick. I mean, Aristophanes did, but that's kind of that's the next one. You'll see that in a second. So basically, those 2 points allow us to basically find out where the center of Majora's Mask is and relative Majora's Mask, Link's shadow. So by using that and a stick, we can tell precisely when the sun is at solar noon. With that out of the way, and now that you understand our really amazing experiment that we did in literally a 1 part of this gigantic video, I'll let this guy talk some more. In the southeast, the sun near Lurelin was always the highest between 12:40 and 12:45 p.m. In the southwest, a whole 10 minutes earlier, which absolutely makes no sense while the sun appears to be moving east to west. And then in the north, both Death Mountain and Rito Village had a noon time between 12:20 and 12:25. North and south aren't even supposed to matter. Who designed this skybox? Clearly they were laying down on the job. Get it? Because it's sideways, north to south. So what does that even mean for us? Well, if the world were a globe, the sun would move evenly from east to west. And the curve of the earth physically blocks the sun, so the sunrise is later as you move west. The east would have noon earlier and the west would be delayed, and north and south wouldn't matter at all. But that's not what's happening in Hyrule. The sundial industry here must be really fun. You need a degree in theoretical physics just to figure out when it's time for lunch. But does that mean the world is flat? No, not necessarily. If you watched our Birds of Zelda video, you already know that the makers of Zelda love a good MC Escher's painting. Maybe they took inspiration for their world building too. But the most likely solution is that Hyrule is on a flat world and the sun just moves in a weird pattern across the sky. So all the evidence we've seen so far has either supported the flat world theory or could go either way. So to try to put the final nail in the proverbial coffin, we dug back into history for one last piece of evidence we could use. What kind of definitive proof could we use to say the Earth is definitely either round or flat? Well, we already crossed Pliny the Elder off our list. But what about Aristotle and Eratosthenes? Well, as the earliest supporter of the globe Earth theory, Aristotle's evidence is limited. He noticed that the Earth casts a round shadow on the moon, which we can see in Hyrule too. The moon becomes crescent because the Earth is round. But we could also explain that with a round disk, which is not good support in either category. But what about Eratosthenes? He was the first person to calculate the size and shape of the Earth with mathematical accuracy. This ambitious librarian in the 3rd century BC used the length and angle of noon shadows to calculate the circumference of the Earth. The key? Measuring shadows at different latitudes on the same day. He started in the city of Syene in Egypt. At noon on the summer solstice, he found that a deep well had absolutely no shadows. That means the sun was directly overhead. Next, he moved to a city due north. On the same day, a vertical stick 422 miles north in Alexandria cast a shadow. That means the sun is at a different angle compared to the Earth in Syene and Alexandria. And incredibly, Eratosthenes went even further. He measured the angles of these shadows from due north. The shadowless well is at 0 degrees. And the stick, 800 kilometers north in Alexandria, was at 7.2 degrees. That's 1/50th of a circle. By taking 100 kilometers and multiplying by 50, he was able to calculate the circumference of the Earth as 40,000 kilometers. And he was only off by 2% from modern estimates. Not bad for a guy from the Iron Age. He calculated the size of the entire planet using a stick. Meanwhile, I struggled to find my way to the grocery store if my GPS loses signal for about 3 seconds. So how can we repeat this in Hyrule? Well, there is no way we can accurately measure the angle of shadows. So instead, we focus on the first part, shadow length. If the world is round, the noon shadows in Rito Village should be longer than in Gerudo Desert. And at first, that's what we found. Even after all that evidence that the world is flat, is this final test really saying Hyrule is on a globe? Well, it turns out no. See, when we did our first round of measurements, the shadows in the north seemed a lot longer than the south. But then we remembered Gerudo Desert and Lurelin Village are at a much lower elevation than Rito Village and Death Mountain. In the real world, minor changes in elevation don't matter much compared to the size and shape of the globe. The sun is incredibly far away that the rays come in at the same angle, regardless of elevation. But that isn't what happens in Hyrule. So, once we controlled for elevation, our results completely changed. We laid a spear on the ground pointing to the north and watched Link's shadow cross over it at noon. And if we keep the elevation constant, Link's shadow was almost perfectly the same length in all 4 locations. But when we went down in elevation, the shadows got shorter. And that is only possible on a flat world with a very close sun. Hi, it's a little darker in here for this demonstration. Think of this like moving your hand towards a flashlight. The closer or higher elevation you get, the bigger the shadow. Move your hand further away and the shadow shrinks. The closer the flashlight is, the more dramatic this effect. With a distant sun, elevation doesn't matter, but in Hyrule, the sun must be practically right on top of us. And what's worse, with all that staring at the sky, we couldn't help but notice something alarming. The stars don't move. You've probably seen those amazingly beautiful time lapses of the night sky on our planet. The spin of the Earth makes the stars move steadily across the sky. But in Hyrule, there is no star movement. None. Add that together with no magnetic field, a cold core, and shadows that act like a spotlight on stage. This is a flat world with no spin, and the sun revolves around it. I mean, I knew Link was a big deal, but I didn't think he was the center of the universe. Okay, but exactly how big is this world then? I mean, it must be pretty big to have enough gravity to make a whole sun rotate around it. Well, we can't say for sure, but we do see that it has fairly Earth-like gravity, and that tells us a lot. See, the gravity of a planet is based on its mass. Every bit of matter in the universe attracts every other bit of matter. So, the more mass you have in one place, the stronger pull it exerts. In our universe, there is a standard formula for determining the gravity of a planet. Gravity of a round planet equals the gravitational constant of the universe, big G, times mass divided by the radius squared. On a flat Earth, it would be a little more complicated. So we reached out to some wonderful research consultants of ours to help us figure out how big Zelda's world might actually be. We talked to an astrophysicist and a geospatial systems engineer to help us mathematically solve Zelda's flat Earth mystery. And once we got through a little bit of calculus, we ended up with this formula. The gravity of a flat planet equals 2 pi g times mass over area. And regardless of whether the world is round or flat, mass is the density of the rock times the volume. A little magic algebra later, and we could determine that if Hyrule has the same gravity as Earth and it's made of the same kind of rock, then the thickness of Hyrule's disk is 1/3 as thick as Earth, which seems pretty small. The only problem? If Zelda's world is thinner, that means it has to be a lot further across to get that kind of mass. Hyrule would have to be on a planet 1.5 times as wide as the Earth. That's not a small planet. And in our universe, an Earth-sized planet would crush itself into a globe. Gravity pulls towards the center of an object. So on a globe, the amount of gravity you feel on the surface is proportional to the radius. And the extreme amount of gravity generated by a planet-sized rock literally pulls all the pebbles and dust into a giant ball. But for a flat world, the amount of gravity you feel is proportional to the thickness. So if you're near the middle of the disk, gravity feels pretty normal. But if you're at the edge, you feel a gravitational force pulling you to the center of the disk. And that must explain all the invisible walls keeping you from leaving Hyrule. Okay, I doubt that last one. But how could Hyrule's world possibly be that big and still be flat? What could possibly be keeping the edges of the disk from collapsing towards the center? Well, it could be the same force that's holding the world together. If you saw our video on if the Triforce is radioactive, then you know that in a link between worlds, the power of the Triforce is literally holding the world together. Without a Triforce, the kingdom of Lorule began to crumble and fall apart, creating giant cracks in the earth and chaos amongst its citizens. The Triforce quite literally held their world together, so we can assume it does the same thing for Hyrule. So maybe it's the divine power of the Triforce creating a force field strong enough to defy gravity that's keeping Zelda's beautiful and flat world from collapsing. But what do you think about all this research? Is Hyrule on a flat world? Are there any tests that we missed? Or any important supporting details to add? Let us know down in the comments. And while you're down there, don't forget to like, subscribe, hype the video, and check out our Discord and Patreon. And finally, I want to give a huge shout out to Leels, who did our amazing thumbnail art for this video. It is absolutely incredible. It's the full time lapse of how this artwork was made at Leels' page at the link in the description and the comment section below. My name is MamaGoron. Thank you so much for watching, and I'll see you on the next one. Bye.
Where have you been searching all along? Confusing twilight on and on, without a clue, without a sign, without grasping at the real question to be asked. Where have I been? I'm a shapeshifter at post masquerade, hiding both face and mind, all free for you to draw.
Man, this video had a lot of different science in it, and we explored the depths and skylines for the first time in the series. I wonder what we could learn if we spent a little more time in the depths. I mean, come on, a valley underneath of a volcano? That place is all messed up. It probably smells horrible too. I wonder if you could even live down there. Like, do you think you could even drink the water down there? Guess we should find out. But for now, I am gonna go get some pie. I'm hungry.
I'm a shapeshifter. What else should I be? Please don't take off my mask.